So you know that feeling. You've got this perfect setup in your head.
Right.
Computer's over here, and the giant screen is way, way over there in the main hall. And then reality hits you.
In the form of a copper cable, it's the classic digital leash. You plug it in, and best case, you get sparkles.
Worst case, just a black hole. Just nothing.
Exactly. Copper just isn't built for that kind of marathon.
Well, today's deep dive is about a piece of hardware that basically cuts that leash entirely.
Okay.
We're looking at the Avenview FO-DVI-1080LC-SET. It's a DVI extender, but instead of copper, it's using fiber optics.
It's a pretty industrial solution to a very common problem, really. You're taking this delicate digital signal and just blasting it across huge distances.
Let's get into the numbers then, because far is pretty subjective.
Yeah.
I'm looking at the specs, and for UXGA resolution, they're claiming 500 meters.
500 meters. That's over 1,600 feet.
And it gets better.
Oh, yeah.
If you step down just a bit to SXGA, you can push that to 700 meters.
700. We're talking nearly half a mile of cable run.
But this is what jumped out at me in the docs. If I want to max this thing out, go full WXGA 1920 by 1200, the distance just plummets to 100 meters. Why does adding a few more pixels cut the range by almost a factor of 7?
Well, it comes down to bandwidth density. Think of the fiber cable like a pipe.
A water pipe.
Exactly. Higher resolution means you're trying to shove way more more pixels through that same pipe every single second.
Okay.
And when you use light to transmit that data, you're pulsing it incredibly fast.
Yeah.
At higher resolutions, those pulses have to be closer together.
They're over long distance.
Over a long distance, you get something called dispersion. The light pulses, they start to spread out, they blur into each other.
So at 700 meters, the on and off signals just smear into a mess.
That's it. To keep the image sharp at those high speeds, you have to shorten the runway.
That makes a lot of sense.
You know?
Now, under the hood here, this isn't just a simple flashlight blinking.
No.
The spec sheet mentions a 4-channel multi-mode VCSL. So what exactly is a VCSL?
Right. It stands for Vertical Cavity Surface Emitting Laser.
Okay.
Unlike a standard LED that just, sprays light everywhere like a light bulb, a VCSL shoots a precise laser beam straight up from the chip. It's incredibly efficient and can switch on and off at extremely high speeds.
And it's using 4 of them.
Yeah, it separates the signal traffic. So instead of one big, messy stream, it sends red, green, blue, and the clock signals down their own dedicated optical lanes.
And that's how it keeps the picture so crisp, even when the computer's a 10-minute walk from the screen.
And it does all of that in a box that's surprisingly small.
About the size of a deck of cards, right?
Okay.
But let's be real, sending the light, that's the easy part. The part that usually ruins my day with these extenders is the handshake.
Yes. The black screen of death.
Precisely. You plug everything in, the light is flowing, but the computer just acts like the monitor doesn't even exist.
That's the e-reader problem. Your computer needs to read the monitor's ID card, to know what resolution to send.
And with half a mile of fiber in the middle, that conversation just fails.
It usually fails, yes.
But Avenview claims to solve this with something they call pseudo-DDC. How is that different from a standard pass-through?
Think of this device like a... well, it's like a very efficient executive assistant standing outside the boss's door.
The boss being my computer.
Your computer. So the boss yells out, "Is the client here?" And the assistant just says, "Yes, right here, send the data," even though the client is actually on a conference call 3 buildings away.
So the extender just memorizes the monitor's stats.
Exactly. It captures and stores the ED information locally, so the computer thinks it's talking directly to a monitor sitting right next to it.
It's a clever workaround. You just lie to the computer to keep it happy.
It prevents the OS from disabling the video port because it can't find a screen.
And practically speaking, I'm guessing this uses standard LC connectors.
Yep, standard LC fiber and a 24-pin DVI-D plug. It integrates pretty seamlessly.
Okay, we have to talk about the elephant in the room. I looked up the price. It's listed at $793.33. That is steep. I mean, that's more than the monitor in most cases.
It's definitely an investment. But you aren't paying for the plastic box. You're paying for those VCS seal lasers and, more importantly, that handshake reliability.
I suppose.
If you're running a medical imaging display or a stadium scoreboard, you just can't afford a $50 cable that flickers.
That's a fair point. Reliability costs money. So, to sum it up, we've got a device that takes the raw digital language of DVI, the TMDS signal,
And it shoots it down a glass tunnel using high-speed lasers.
all while tricking the computer into thinking nothing unusual is happening.
It's a seamless illusion that keeps the data flowing.
You know, it really makes you wonder, if this device works by faking a connection, how much of our other seamless digital experiences are just frantic little algorithms lying to each other to keep the whole system from crashing?
I think if we look too closely at the back end of the internet, we'd find a lot of assistants making things up just to keep the bosses happy.
Something to think about next time your screen flickers. Thanks for listening to this deep dive.